Good evening, everybody. It is a special video discussion to basically break down the upcoming storm that we're going to be dealing with. The reason why is because, well, as always, the NAM is being the NAM. Now, with that, there's been a lot of misunderstandings on what exactly we're going to be dealing with this storm. So I wanted to make it very clear and explain what's going on with the NAM and what's going on with the current conditions right now. And then with that, we can add in the rest of the forecast, and I'll break all that down. The premium members, you already got the updated forecast. The public map just got sent out as well. So let's go over what we can expect here with this pattern. So let me go back to here. Okay, so right now we have warm air surging in, and that has produced actually a few renegade showers that well out ahead of the actual storm and warm front that's associated with this storm. You can see temperatures throughout the region are well above freezing, very warm out there, with our dew points also rising up very, very nicely. I would not be surprised if we get a little bit of low clouds starting to develop towards midnight before the winds start to become too strong to prevent any type of fog development. Now, currently, when we take a look at our radar and surface map from WeatherTap, the thing that's really standing out here is all of the thunderstorms that are taking place around the Mississippi River Valley and up towards the Tennessee River Valley. We've seen some very impressive thunderstorms capable of tornadoes, a very impressive tornado data coming out of portions of Tennessee and portions of Mississippi. It's been nasty up there. Now, this convection is a warning sign. This is a very dynamic storm that's starting to evolve here. And you can see a wave of low pressure trying to develop down here in a very dynamic cold front and the current primary low up here towards the Great Lakes. Meanwhile, we have a battle between the warm air that's surging northward and the maritime air that's trying to put up a fight. This is kind of a maritime modified polar air mass up around here. So all these different frontal boundaries are kind of interacting here. So you have the maritime air mass up here down to here with the warm front over here. You got a modified Pacific air mass here, modified tropical air mass here, and then a pure tropical down here surging northward. So a lot of different air masses combined with the polar air mass also coming into play. So you have about five different air masses all interacting in this storm with different aspects to each one of those air masses combining to create a very dynamic situation. Now, when we take a look at a lot of our data here, this is from the SPC website. You can see the warm air surging northward. Here comes our cold air, and pretty dynamic cold air, minus 8 degrees Celsius already diving southward. When we take a look at some of the factors here, first of all, precipitable water values are surging northward. The moisture transport 850 millibars is getting stronger by the hour. We are seeing some dynamic factors here in terms of the bulk wind shear down here supporting our thunderstorm threat. So a lot of turning of the winds down there. And the reason why that's important to us is that it kind of gives us an idea why some of the mesoscale models are having some difficulty and even some synoptic models, because there's a lot of convective feedback issues because of so much latent heat release going on here. And you can see the deep convection here, just starting a moisture convergence here, really taking shape here around the Tennessee River Valley. So when we take a look at these factors here, and we see the moisture surging northward and starting to see some convergence taking shape here, this gives us a warning sign of how to handle the models and all the different factors as this storm evolves. And another thing that really stands out to me is the vorticity here from 400 millibars to 700 millibars, very strong dynamic. And see this feature right here? This is quickly diving south. And you can take a look at the upper level winds here. Look at this feature. We got a positively tilted trough. So initially you would say, okay, progressive moving storm. And that's how our low pressure system rapidly heads up towards our region. But because of this jet streak here, this is a sign that this trough is about to go into a negative tilt. It's about to go through that process. And that's really important because what that means is that you're going to end up with a lot of divergence and diffluence here. So all these factors are coming together. You're seeing that the jet stream circulation is really starting to organize here. Look at this divergence and diffluence starting to take shape in the Ohio River Valley, getting ready to head towards our area. And of course, you have the moisture transport and the warm air transport all taking place at various levels. So the initial stage here of the storm is pretty clear. Very heavy rainfall is on the way here because you're seeing several different factors combining here in the observations. Moisture transport, deep tropical moisture transport at that. You're seeing a thermal gradient developing, and you're starting to see the beginnings of the trough shifting from positive tilt to neutral tilt and eventually to negative tilt. So a lot of changing in the wind's direction from the surface all the way up to the upper levels. All these factors are all coming together. So you have all that playing in. You can see the 850 millibar jet stream here is starting to intensify as all these changes are starting to evolve. Here's our primary low right now, drawing all that moisture northward. And that's showing up very nicely here on the infrared satellite picture with these thunderstorms. So intense lifting here, a lot of energy being released into the atmosphere, a lot of different dynamics. And this is only going to enhance your thermal gradient as all these processes are taking shape. So while this is all happening, our jet streak is also intensifying. But notice, look at this spread starting to develop here. So you're getting stretching in the upper levels of the atmosphere, divergence and diffluence aloft. So again, this is all rising motion. All the air is rising very, very fast. And as that is evolving, the setup here for our secondary low can already be observed. I'm going to explain why. You see this feature right back here? This is going to really kick start this trough to going from neutral to negative tilt. It's going to start to take part of some of this convective release, latent heat release in the atmosphere, increase the thermal gradient. And it's also going to increase, as that low pressure system develops along the coast, the cold air transport, but also the dry air transport. So, how do you work all this? This is where being a meteorologist is very important and not just following the models. Okay. So we have all of these factors coming together. And really, the synoptic models really have not changed all that much. Very strong lifting here. It's a storm that is going to be starting to impact the region tomorrow morning with scattered showers, more widespread rainfall for tomorrow afternoon. In the evening, it gets very strong. You have all of the lifting parameters here around midnight for a line of thunderstorms, low top thunderstorms marching through the region. And with those thunderstorms, that is where I'm going to expect the strongest peak wind gusts being a threat here, which we've been talking about for several days now. So we have all those factors coming together. The question is, as this mixing is taking shape, and these are the upper level winds, again, the divergence and diffluence, here's that negative tilt that we're talking about. Seeing that here at 500 millibars, that negative tilt, 850 millibars, that low level jet enhanced by that negative tilt, all that is coming together. The question now comes down to how much moisture is left Monday morning. Look at the strong dry air transport. As the cold air invades. And that, ladies and gentlemen, is the last question to this whole storm forecast. We got the rain, we got the thunderstorms, to get an idea, we got to deal with very heavy rainfall. The primary question that's left over is, will we have accumulating snowfall Monday morning as the storm departs? And of course, the main question really comes down to timing. Now, as you know, let me pull up the NAM because everyone's focusing on NAM. Everyone's been looking at this data. And yeah, you have strong cold air transport here at 925 millibars and 850 millibars. But the problem here is the boundary layer and the urban heat island effect. I love the idea of accumulating snowfall and a couple of inches in your higher elevation, especially north and west of the I-95 corridor. especially in the Poconos and Catskills. That's been the theme. But the coastal plain, you're going to see some snow out of this. It's just going to have a very difficult time accumulating. And one of the things I was looking at with the buff kit data is that the changeover process, while there is strong lifting involved, even with that strong lifting involved, the snow support is marginal at best. And the snow ratio as a result, maybe 6-1. A lot of these snow models, a lot of people are looking at with the NAM, well, they're 10-1 ratios. That's not going to be the case. Now, the one thing we're going to have to watch out in this setup is that as the rain changes over to snow, it's going to be heavy at first. And will that intensity overcome the warm boundary layer, which already was in the 60s and 50s? But at the same time, how much time is left really to support that transition? So when you're looking at all these factors, and then you look at the synoptic scale models, you kind of have to mix them together. All right. The NAM's probably a little bit too cold. The European guidance here is probably a little bit too warm. So that's how you end up with this forecast. And for premium members, if you become a premium member, if you're not already, only $15 a month. This is where you can use the Google Map models. You can zoom right into your backyard. So you don't have to ask me what snow is going to be in your backyard. You can just zoom right into it. For your higher elevations, Scranton, uh, turned come I'm not even going to pronounce that one, but you get the idea. Up towards northeastern Pennsylvania, higher elevations, looking about half an inch to an inch and a half of rain, snow 5 to 7 inches once it changes over. The time period to change over looks to be after 10 p.m. Tomorrow. And yes, there will be a threat for slick and icy roadways there. A little bit lower in the elevations as you get to south of around Wilkes-Barre. Let's see here. Hornsdale, down towards Harrisburg. Those locations, 1 to 2 inches of rain. At the changeover, 2 to 5 inches of snow. A lot of that's going to be on cold surfaces. Roadways, especially any treated roadways, will have a difficult time accumulating. The precipitation is expected to end at 9 a.m. Again, threat for power outages, some minor flooding. As you get to the suburbs of New York City and Philadelphia, the northwestern suburbs, including areas like Lancaster, Allentown, King of Prussia, up towards Wigapen Falls, New Plaza, Poughkeepsie, locations like that, you're looking at heavy rainfall, 1 to 2 inches of snow mixing over by around 4 a.m. and continuing until about 10 a.m. So right around your morning rush hour, just great. Again, trace the 2 inches of snow. A lot of this on cold surfaces. There will be some slick and slushy roadways. Definitely use some caution there. There will be a threat for power outages at wind gusts between 20 to 40 miles per hour. Now, the area where I'm expecting the most significant wind gusts is along the coast here. So your I-95 corridor and towards the coast. In these locations, primarily we're looking at heavy rainfall. I'm worried about some urban flooding and flash flooding, 1 to 3 inches of rain, wind gusts 30 to 50 miles per hour. The further east you are, the more likely you're going to see those wind gusts pushing over 50 miles per hour in some locations. And a lot of that is going to be within the thunderstorms that are going to be progressing with this cold front. So you're going to get heavy rainfall, thunderstorms, wind gusts. As those thunderstorms move through, then the temperatures start to crash. And as those temperatures begin to crash, that's when we start to open up the potential for snow mixing in. But that's going to take some time to get to the coastal plain, to the point where most of the precipitation will be over once we support those 925 and 850 millibar temperatures supporting the snowfall. So looking at a changeover from 7 a.m. to 12 p.m. Monday morning, and a lot of this snow initially is not going to stick, especially on roadways, but I do like the idea of maybe a trace of snowfall or a nice little dusting on your grass. This is going to be a very wet snowfall, so don't be surprised 7, 8 a.m. You got snow falling, but not really accumulating much on the roadways, especially anything that's treated, especially with the urban heat island effect, with temperatures being in the 50s and 60s, just a couple hours beforehand. The strongest lifting while this process is happening is all going to be shifting up towards New England. And so that's why we're going to be losing that component of the potential of cooling. Okay. So that's where I'm seeing this storm. Again, if you have anything outside, I'd bring it inside or secure it. And with the heavy rainfall, I would not be surprised to see some localized flash flooding and urban flooding out of this as well. That is your update for today, for tonight. We'll continue to keep an eye on this for tomorrow. And as always, stay safe out there.